Hello, my friends. Suppose you need to deploy a multi-node YugabyteDB cluster that spans multiple regions. You have probably come across terms like the preferred and primary region. What are they? How do I work with them? Let's get this figured out. Let's start with the preferred region. Imagine you have a multi-region cluster used by a pizza chain with customers in the United States East, South, and Central. Now, all these regions are equal. None of them is designated as the preferred one. This implies that customer orders will be distributed evenly across all the regions. All the nodes will be handling both read and write requests. Then you decided to designate the US East region as the preferred one. Perhaps because the pizza chain has a significantly larger customer base in that area, and you want to optimize the read and write latency for that location. Consequently, the database nodes from the preferred region will hold the primary copies of all the pizza orders. The same nodes will handle both read and write workloads, reducing the number of cross-region requests. Hands-on time. Let's create a cluster with a preferred region using YugabyteDB Managed. Choose your favorite cloud provider, set the data distribution mode to replicate across regions, and configure the regions we discussed earlier in the United States East, South, and Central. Remember, a significant number of the pizza chain's customers is on the United States East Coast, so mark that region as the preferred one. And finally, create the cluster. Once the cluster is up and running, the YugabyteDB Managed dashboard will consistently remind you that the US East Coast is set as the preferred region. What latency should your customers anticipate with this cluster configuration? Well, it depends. When a customer from Chicago places a pizza order, the latency might be around 95 milliseconds. This is because the request first travels 800 miles to the preferred region on the United States East Coast, and then the node from the East Coast replicates the order across the South and Central locations. However, if a customer from New York City places an order, the latency will likely be halved at roughly 50 milliseconds. This is because the customer lives near the preferred region and only needs to wait while the data gets replicated across the South and Central locations. That concludes our discussion on preferred regions. Alright, now let's delve into the concept of the primary region. This term is used in conjunction with the geo-partitioned deployment mode. Imagine the pizza chain expanding internationally, opening new stores in Europe and Australia. They have now transitioned to a geo-partitioned YugabyteDB cluster, which automatically pins pizza orders to regions based on the customer's location. So, orders from the US are directed to the US, those from Europe to Europe, and naturally, orders from Australia are stored in Australia. However, there might be certain tables that are not geo-partitioned. These tables are stored in one specific region, and you guessed it, this region is termed the primary. For example, in the case of our pizza chain, the primary region is on the United States East Coast, and data about pizza ingredients is exclusively stored in that location. Let's use YugabyteDB Managed to create a geo-partition cluster with the primary region in the United States East Coast, and then run a couple of experiments. Proceed as follows. Choose your preferred cloud provider, configure the data distribution mode to partition by region, start nodes in the United States East Coast, Frankfurt in Europe, and Sydney in Australia. Ensure that the US East Coast is designated as the primary region. Finally, start the cluster. Once the cluster is operational, it's time to simulate customer interactions. The pizza orders table is geo-partitioned, which means orders are assigned to regions based on the customer's location. For a customer in New York placing an order, you can anticipate latency in the single-digit millisecond range. When that same customer checks the order status, latency should be approximately 4 milliseconds. Now, what about a customer in Australia? Just as in the United States, it's roughly 8 milliseconds to put a new order into the database. Additionally, the read latency for the checking the order status remains in the single-digit millisecond range. This consistent performance across various locations demonstrates the power of a geo-partitioned YugabyteDB cluster. Now, recall that the pizza ingredients table is not geo-partitioned. This means all its data will be stored in the primary region, which is the United States East Coast. After setting up this table, let's introduce a few ingredients and measure the latency from both the US and Australia. When you fetch ingredients from a location near the United States East Coast, expect latency around 2 milliseconds, primarily because you are close to the region housing the data. However, if you query ingredients from Australia, the latency will naturally be a bit higher. This is due to the request traveling the considerable distance from Sydney to the United States East Coast to retrieve the information. Alright, mission accomplished. Now you understand the distinction between preferred and primary regions. Take care and see you next time.